Hello there. Today we will be doing shortest sublist to sort. Given a list of integers, um, return. Oh, sorry. All right. So this will help me read it and see the camera at the same time. So given a list of integers nums, return the length of the shortest sublist in nums, which, if sorted, would make nums sorted in ascending order. So here's the example. Nums 0, 1, 4, 3, 8, 9. And the output is 2 because we need to sort 4 and 3. In this particular example 2, we need to sort 5, 4, 3, 2, 8, 9, which is 4 because we need to get 2, 3, 4, 5, 8, 9. And in example 3, 1, 2, 3, 5, 9, 8, 5. As you can see, we need to sort 3 because we need to move to 5, and the 9 in the play three items, these 3 items, right? 985. So to do this, there are 2 ways that I'm aware of. The first way is an n log n method. This means that we will be using a sorted list to be for comparison. And if we have anything that is not of in correct order, we will then make sure that to record that the index of where it is not in order. And if we have more than 2, that means that we need to subtract the 2 numbers. If we have less than 2, then there are no issues because you have to have 2 to swap. So then we just return 0. This is our first method. It will be O of n log n. And we will have another method, a O of n method, where we'll sweep both sides. So we'll sweep from the left to the right and the right to the left. From the left to the right, we will sweep through the items and find out where we end, where the issue is. So where we are not in order. And then we sweep from the right to the left and find out where we start to become out of order. Finding these 2 locations by creating the most current the item max number, and if anything is less than that, then that's out of order. So in both ways, or less than, we can get start and the end of this particular this section of the array that is out of order, subtract them and add them together, and we will get the particular answer. And so let's start with the n log n way, and we'll move on to the O of n way. So we need a way to store the items out of order. Items out of order. Unsorted items. Let's call this index because we're storing the index rather than the items. So I is equal to 0 for A and B in zip. Longest nums and sorted nums. So we zip the 2 together. If A does not equal to B, ones not append I plus equals 1. Return 0 if length ones is less than 2, else ones minus ones. So this is the biggest index minus the smallest index plus 1 to recover from the loss of subtraction. And we'll return. Sorry. May. Oh. 係教課啊，唔係香課啊。Okay, so it looks like it was a success. Sorry about the intrusion there, but that's the way it is. So we have the success here. It is very successful. This is an n log n method. It will require O of n space as well. All right, so second method. Second method, we need to take care if not nums, we will return 0 because there's nothing to do. Because we will need to get the first item, num0. Then n is equal to length of nums, end is equal to -1, and we're going to find that end right now. So for I in range 1 all the way until n, we will do a nums if I is less than left max. So if any item is less than the most left, the max item that we have reached until n is equal to I, and then left max is equal to the new left max. So if n was not found, we can be for sure that there is nothing to sort. So this is going from the left to right side. So for example, let me get some tools here. Bring this up. All right. So I have this like nice little highlighter. Okay. So nums I. We started here. Left max is equal to 0. So n is still -1. Okay. We go up. Nums is still equal to 0 because actually it is now no longer left max. It is no. Well. Okay. So O of 1, 0 is the current number less than sorry, it was supposed to be greater than isn't it? So numbers left max. So 0 is so we start at 1. Left max is 0. 1 is not less than the left max, so n does not change, and then left max is now equal to 1. We move on to the next number, 4. Is 4 less than the left max? No, it is more than the previous max, so n does not change. We set left max to 4. Then we see 3. Is 3 less than 4? 3 is less than 4. So the end is now set at this particular index. 0, 1, 2, 3 at 3. Then we will move on. We will still have 4 as our max. And we set 8. 8 is not less than the 4. And so we keep the n at 3, and left max is now 8. And we repeat, and now left max is 9, and we end is still at the 3. So this is where it has become the last endpoint where it was unsorted. Now we need to find out where it starts. So we're going to start at this end and move down from the right to the left and see where it begins to unravel the sorted items. So we have the right min is equal to nums -1. Start is equal to -1 for I in the range n -2, -1, -1. If nums I is greater than right min, start is equal to I. So this is basically like the opposites of what we just had earlier, where instead, if it is greater than the right minimum, then we will set that as the start point. So what I mean by that is, so let me just type out this bit first, so what's going on here is that, let's say you start at 9, and now if this particular number is bigger than the right min, which is now currently 9, then it is out of order. So 8 is not out of order. 8 is now the next right min. 3 is now the next right min. Now 4 is greater than 3. So the start is now at 2. So we set the start at 2 and end at 3. So right min is still at 3, and this is less than 3. So it's 1, right min is 1, right min is 0, and start is at 2, end is at 3. Alright, hopefully that clarifies everything. And we will move down to the last bit of code, where we return the last bit of the start, the end minus the start, and we need to make up for that lost index, which is adding 1. So let me get this whole code in frame at the end. I'll just submit the code right now, and we'll go from there. Run, submit. Perfect. So this is going to be a O of n time, because we go through 2 loops, and O of 1 space, because we do not generate any sort of space that we need to store. So this is faster and saves more space than the previous solution. If you have any questions, please comment below. If you like the video, please like, and if you like more videos, please subscribe. There are also links below in the description that will link to other algorithms and my personal website that shows more interesting iOS development projects that I've been up to. So thank you very much. To see you again. Have a good one.